For a particular clothing store, the claim is that the mean age for all customers is 25 years old with a population standard deviation of 9.84 years. The store manager feels that the average age is much different than 25 years old. A survey of 30 randomly selected customers gives a sample mean of 31.84 years. Let alpha equal 0.05. The first question asks, what is the level of significance? The level of significance is just your alpha level, so the answer will be 0.05. Next, you go into stating the hypotheses and then determining if it will be left-tailed, right-tailed, or two-tailed. To state hypotheses, you always have your null and alternate hypothesis starting with the null, and that is depicted as h sub 0 with a colon, mu equals, and then you determine what it equals. As it says in the paragraph, it says the mean age for all customers is 25 years old. Mean is average, average is mu, so it'll be 25. The setup for null hypotheses always starts with h sub 0, colon, mu equals, and then you're the one to determine what the number is. The next step is to do your alternate hypothesis, which is h sub 1, colon, mu. You determine what goes in between, and it's still the same number as the one above. So as it says in the paragraph, the store manager feels that the average age is much different than 25 years old. So since it says it is much different than, it'll be does not equal. Next step is to find the sampling distribution and to explain why you use it. For this one, we will use a standard normal since the population standard deviation is given. And this can be seen right in the paragraph where it says population standard deviation is 9.84 years. If it doesn't say population standard deviation, you will then use a t-table or student's t-table for your sampling distribution. Now we get into actually using the standard normal when finding the sample test statistic. So we will use the equation z equals x bar minus mu all over the quantity sigma divided by the square root of n. Up in the paragraph that we were looking at, it gives you all of these quantities. So x bar is 31.84, your mu is 25, then you divide by your standard deviation, which is 9.84, divided by the square root of n, which is your sample size, which is 30. When you do all this math out, it becomes 3.81.